Right, number 5. For each of the following sequences, either arithmetic or geometric, we're going to find a possible function for the domain who is a set of natural numbers. So we're starting with the numbers 1, 2, 3, 4, 5, using them to label each of these sequences. So the first one, we have 4, 11, 18, 25, 32, so on. Alright, so we want to see if it's arithmetic, easiest. They're getting bigger, so I want to see if we're adding. Looks like 7. Here, also a difference of 7. Okay, so my common difference is 7. I'm going to use the arithmetic formula and then simplify. You start out with your first term, which is 4, plus the difference, which is 7 times n minus 1. And I'm going to distribute, and this is going to give us 4 plus 7n minus 7. And then combine the 4 and the 7, and this will give me 7n minus 3. Okay, so this will be our function for the first sequence. 7n minus 3. Alright, for the next one, we have 4, 16, 64. So this is getting really big, really fast. 4, 16, 64, 256, etc. Alright. So, definitely not adding something because the difference here is 12. Difference here is a lot more than 12. So, let's try multiplying. So, if we multiply times 4, 4 times 4 is 16, 16 times 4, 64. So, geometric, you would do your common difference. First term times the common difference to the n minus 1 power. Alright, so basically we're going to add 1. When you multiply same base, you just add the exponent. So you have this 4, 1 plus the n minus 1, and those 1s will cancel out. So you just end up with 4 to the nth power. So when n is 1, you get 4, n is 2, you square it, so forth and so on. So we get 4n for our second function. 4 to the nth power now, 4n. 4 raised to the nth power. Alright, C is all 4s. What you notice is a constant function. So this is kind of like a y equals 5. No matter what x is, 1, 2, 3, 4, 5, you're just getting that number. So there's nothing to do here, just to understand it's constant. So the function here would just be whatever that constant is. In this case, it would be 4. And then D, our last one, we have 4, and then we have 4 to the 4/3, and then we have 4 to 5/3, and then we have 4 to the 2nd, which we can also write as 6/3. Okay, 6 divided by 3 is 2. So, and I can probably do the same thing here. They're all thirds, so I can say 3 to the 3rd. So what's going on? This is my first term, second, third, fourth. I want to use those numbers 1. And I'm adding, looks like 1 to the numerator of the exponent. Okay. So if I wanted to use 1 in here, somehow, what we're doing is adding 1. So basically I want to let take away 1 and say that this is 4, and n is going to be my 1 because n is what I'm adding every time. N, we'll just say plus 2, because when n is 1, 1 plus 2 will give me 3, which will give us just 4. And if I did that here, and it's over 3 of course, if I did that here, n plus 2, it would be 2 plus 2, which would give us 4, and so that would match. This is what we need here. So just kind of look at what's adding and figure that n into that numerator like so. Adding 1 here plus 2, whatever the n is, plus 2 will give you the numerator. And then the function we need here is just 4. We're going to raise it a fraction, and we're going to have n plus 2 over 3, because all the denominators are going to be 3 in that scenario. Sorry, we couldn't see the 1, 2, 3, 4 up there.